Okay, welcome to the Matlab lecture 10. We're going to be going over 3D plotting, and so first off, I'm going to make a little file. It's going to look a little bit familiar to lecture 8, which was 2D plotting, because a lot of the commands are somewhat the same, but I'm going to go over the little differences that make it 3D plotting and not 2D plotting. So first off, when you make a 3D plot, you need an X, Y, and Z axis. So I'll have to first, I can do this in command window actually. I have to first specify what my X and Y axes are going to be. So I'm going to first start off with saying this matrix XY equals a mesh grid. And mesh grid kind of just I'll show you. Mesh grid will return basically every single X and Y value in between two ranges. So if I say from 1 to 16, 1 to 16, as you can see, we have an X. Our X cell has all of these numbers, and our Y cell has all of these. So when we plot this graph, it will go through every single point that I've specified up there. And then I'll say z equals some function that we want to graph. So I'm going to make this one a little spicy, so let's just say this is going to be equal to y times the sine of x. Now let's see what that looks like. And I'm gonna make a mesh graph of this. So when we do this, we get this figure over here, and this is what y times sine of x looks like. So with these little controls in a figure window, you can move the graph around and kind of take a look at it. You can use that to zoom in, and you can move around, look at the function. So that's pretty neat. You can also do just mesh Z, but that would kind of change the size of the, well, I guess it didn't change the size of it, but normally that would change the size of what it's plotting. So, okay, so it looks exactly the same. So using this first one over here, mesh XYZ, I can kind of change the resolution of this graph. So let's say if I wanted to do, if I wanted to be like twice as much detail as I did last time, I could do something like this. That will make this big matrix, well, these two big matrices here twice as big. And then if I do mesh XYZ, we're gonna have a more, okay, what just happened? I have to update Z. Okay. If I do that, I'll have a much more detailed graph here. And if, say, I wanted to plot more of this, I could say I want to plot all the way to 32. And then I'll assign that to Z. If I do that, we can see more of the graph than we did last time. And it doesn't have to be like a perfect square like I keep doing it. It could be like 32 in X direction and 16 in Y direction, and if I do this, yeah, then it'll kind of like flatten itself. So it's pretty flexible, but it works pretty similarly to the 2D plotting part. So let's put this into an actual file. So I'm gonna have X, Y, equals mesh grid. So mesh grid is important whenever you want to do a 3D plot, so it appears on the XY plane the way you want it to be. So let's say 1, 32, 1, 32. And z, this is your function here, so this can be, you know, whatever you want in terms of x and y. So I can do something different this time, so let's maybe do something like exp and then let's do like cosine of y. Let's see what this gives us. Divided by x. That'll look pretty interesting. And then I'm gonna do a mesh of this. So x, y, z. And let's see what we get. I first have to save this. So I'm gonna call this I can do this example 3D plot 2. And this will all be on a GitHub repository, so you can take a look at it later. And when I run this, I have this pretty interesting looking thing right here. Looks pretty neat. So let's start adding a title and axis names, so just like we did in the previous lecture, because like I said, when you want to present this to other people, you're probably going to want to label everything, so it just doesn't look like this. So to do that, this is just like in 2D plotting. I can make a figure, so I can say "3D plot" because I can't think of a better name. And then I have this mesh here, and it will plot that. And then I could specify a title for this, so let's just say 3D plot. And X label, X axis, Y label, Y axis, and Z label, Z axis. And when I run this, it should show all of that. I think let me give it a moment. Okay, let me try this again. No, I think we have an error. We did something wrong here. Oh, can we not use figure like that? It is interesting. If I get rid of this, at least it should work. Nope. It still doesn't want to. That is really weird. Okay, I think maybe the issue was that I put it there. Nope, it still doesn't want to run. Okay, I feel like that is the problem. So I'm gonna keep trying to figure this out. Line 4, column 1. No, that just doesn't show an error. That's really weird. Okay, I'm gonna see if one of my earlier files from the notes work. Why is it not doing it? Okay. So I'm gonna say this right here, this runs in Matlab, and you can see on the notes that what the results look like. I don't know why I can't show like a title, X label, Y label, and Z label, but it is what it is. Yeah, I don't know why it's not working. Oh, did it just stop? Oh wait, I think you might know the problem. Okay, you have to say close all. Because it assumed the window was still active, so it was trying to update a window that didn't exist. So remember, this is important. This is this right here allows you to close all the existing figure windows, so every time you run this it will be refreshed. So I'm gonna go ahead and see if I can add back the figure. Okay, I think I forgot an argument, that's why. Okay, yeah, there you go. 3D plot, and this shows up, and we're all happy now. So there's a lot of more like detailed things that you can do with these commands here. A lot of them are kind of similar to 2D plotting. Like you can add a legend to this. I don't know why you want to add a legend instead of putting it in a separate graph, but you could. You could use the hold function to plot more than one of these graphs on one window. So if you can manage to fit all of those in one window, then it wouldn't stop you there. Then I guess a legend would make sense. And you can also do different kinds of graphs. So this is a mesh here, but I can also do a surface. So let's make this a subplot. And you can do subplots with this as well. So let's say subplot 1, 2, 1, and subplot 1, 2, 2. Let me copy this. Now if we do surf instead, it will be a surface plot. And when we have this, we will have two of these plots here. So as you can see, surface is different because it actually, colors the area in between the lines of the mesh. So good for different purposes. And there are other types of graphs as well. I put them all in the notes, but these are the two major ones, mesh and surf. Let's see, I wonder if I can do surf L. Okay, well it looks a little bit different. So surf L is supposedly one of lighting, but I think it doesn't look right because the lines are there. So let's actually remove the lines. So to remove the lines, I can either probably put it in as an argument somewhere inside of surf L, but I can also call it as an object. So okay, I can do it as an argument. I believe this is an argument. Lines, none. Okay, that is not an argument. Oh wait, I forgot a call. Okay, that works like a charm. Alright, that did not work, so I'm gonna see. But there are a lot of different ways you can customize the graph. So, oh, okay, I found the argument now. Edge, color, and we can set that to none. And let's see. Nope, still doesn't work. Okay, I'm going to try calling this as an object. So I'm going to assign a variable s to this, and then I'm going to say s dot edge color equals none. Now let's see if that works. Okay, well the edges are still there, but I didn't break it this time. There's a way to do like what you want to do usually. I'm just not doing it right, but you can customize this graph. You can make it different colors as well, and things like that. So surf L is supposed to make like a smooth version of the surface that has better lighting. It's a lot more advanced, but you can look it over in the MathWorks website and in more detail with that. You could probably make a really cool desktop background with one of those. In fact, I will encourage you to do that after this lecture. Just make a really cool background and set that as a desktop background, because you could totally do that with SurfL. So I don't really have that much else to cover, but there is something I wanted to do. I wanted to see if we can make the Matlab logo in Octave. So let's make a new file. We're going to call this logo. And there's more detailed instructions of how to make the Matlab logo on the MathWorks website, but for the purpose of not like directly plagiarizing them, I'm just gonna simplify it a little bit. So we can first off start with our figure. So that's gonna be 160 times membrane. Membrane is a command in MATLAB that just it's like a hard-coded function that will give you the MATLAB logo graph. F equals figure. Okay, I'm gonna copy this. I guess surf and surface are different. And okay, so this is where I got the edge color function. It's from surface apparently, so it doesn't work on surf. So this is basically how you call an object of the surface, or like actually a lot of functions in MATLAB have this. When I do something, I like put an argument inside a function like this, like figure name MATLAB logo. I could also do something like f dot name equals and like so and so. So that's what this is what this means. I'm basically passing a parameter after it's been made, so it is pretty useful. And you can do this for pretty much anything that has parameter like this. So I can say edge color none. And it wants me to set specific limits. So this is on the MATLAB website. It's very specific in the limits, so we get the perfect area for those. And then this is for the camera position. This is really extra, but this is just for. Okay, I only have to declare a. So you don't need to know all of these, but these are all useful. Like these over here are just so it sets the position correctly when the window opens, so you don't actually have to move it around. And then those are all the lighting. And this is the most important part. S.face color equals and whatever they put here. So you can change the color of your graphs in the parameters or after you do it. So face color and this vector of 3 values is known as a color map. I can't exactly explain to you how this works, but think of these as RGB values. Or you can use sets of 3 decimals like that, like sets of 3 floats, like in this way. They also have named colors, so like white, black, blue, red, yellow, green. Then you can do something like that. But so these are custom RGB values in them. These are all the complicated commands for the lighting. And then this turns off the axis, so we don't see the axis that we usually do, and this sets the background color. So let's see if this works. And it didn't work. So let's see what happened. Now it's possible, since this was supposed to be for Matlab, so maybe this wouldn't work because Octave isn't powerful enough. So I'm just gonna go comment this out. That is not the comment. Okay, it's Control R. I'm gonna comment this out. I'm gonna comment this out as well. See if this works. Nope, still doesn't like it. That is really weird. Won't let me do that. So if I remove this, I wonder if it will work. Hope it won't work again. It might be asking me to close the windows like it did last time. So I'm gonna try that. It keeps trying to debug. Okay, it just hates every single part of this program, so I'm not gonna bother trying to fix this, but it is possible to graph the Matlab logo in Matlab. So I'm gonna see if I can just do it really quick here. Maybe I can just... Oh, it just doesn't know what membrane is. I guess it's a Matlab only function. Well, I guess I can't really do an Octave, but it is definitely doable in Matlab. You can get the Matlab logo in Matlab, and it looks pretty cool. So I highly recommend trying to do it yourself. Anyways, if you have any questions, I'll be on a Discord. You can ask me after the lecture. And I wish you good luck with plotting and all of that. And I'll see you in 2 weeks.